Now the very last step in this assignment is to explore that we've calculated the coefficient of areal correlation, so we have the area that's in common. But what are the areas of omission and commission? That is, areas that are omitted when they should have been included and areas that are included when they should have been omitted. So to do that, we can sort of see that when we look at the union, but the union doesn't do a very good job of giving us all of the information that we need. So this gives us a perfect opportunity to explore symmetrical difference. If you look at what symmetrical difference does, is it erases what they have in common and leaves behind what they don't have in common. And we can use the results of the symmetrical difference to evaluate those errors of omission and commission. So for symmetrical difference, the input features are the input feature will select as the hand-drawn watershed, and the update feature will be the arc shed, and we'll call this SymDiff shed for the symmetrical difference shed. And now let's take a look at what that output looks like. So the symmetrical difference shed, if we open up its attribute table, it has the hand-drawn watershed. I just noticed I had a typo in there, and the ArcGIS derived watershed as the two polygons. And we actually need to recalculate geometry so we can get the areas of each of those. So we will go to km squared and calculate geometry, and we will make it square kilometers. So we have the area of the hand-drawn watershed and the area of the ArcGIS derived watershed. And to actually visualize which is which, it's kind of hard to tell from the attribute table. So the best way to do this is to go into its own properties and symbolize these by their label. So if we symbolize the shapefile by its label. So if we go to symbology, we want to actually go to categories, and the category I'll pick is the first label, and I want to add all values. I want to add all values, and so I have the hand-drawn watershed, and here I can write as my label arc, because it's the other one, ArcGIS watershed, ArcGIS derived watershed, and here I will fix my typo, watershed. Okay, so now I have a shapefile where I've symbolized my areas that this is the area that came from the hand-drawn watershed that was part of the ArcGIS watershed, but and here's the area from the ArcGIS watershed that was not included in the hand-drawn watershed. So you have those two different areas of omission. So if we highlight this one, the 0.04 square kilometers are parts of the ArcGIS watershed that are not included in the area of overlap, and the 0.00715 are those areas of the hand-derived watershed that are not included in the ArcGIS-derived watershed. So you have a way of getting at, using symmetrical difference, those areas that are evaluating those areas that are not that 8% or so, that's not part of that 91% overlap, where they were, what's the difference between the two inputs. So this is an important way of being able to evaluate the results of what's not included when you have a coefficient of areal correlation. So you can decide which you think is the best input. If you think that your hand-drawn watershed is the most accurate, you could get a sense of what was omitted from that, and vice versa. So I want you to think about errors of omission and commission and what we did in this exercise, and further consider how this can be applied to other scenarios. And in addition, the purpose of this was to just show that there is a difference between the art and science of watershed delineation and computer-derived watersheds. And even though it wasn't much of a difference, if we assume that our derived watershed from delineating it, delineated watershed, if we assume that that is the most accurate watershed, we can use these techniques to see how far off the computer-derived watershed is and where the differences exist in the results. So hopefully that clarifies the rationale behind this assignment. And if you decide to do this on your own with a different pour point, I invite you to do that and understand that you have to be very careful where you put the pour point. And I hope that you have fun exploring this assignment.